Hello and welcome to Algebra 1, Chapter 3.3, and today we're discussing linear functions. So what's a linear equation? Well, a linear equation is the equation of a line that can be written in the form ax plus by equals c. So one thing to note is we're going to be talking about linear equations, and they are going to be the equations of lines. So hopefully you see that connection there. Alright, so we're going to write them in the form ax plus by equals c. That is standard form for a linear equation, so you're going to need to know that. To correctly be in standard form, you need all three of these requirements. A has to be greater than or equal to 0, which would mean it can't be negative, so A can't be negative. A and B both can't be 0, because if A and B were both 0, you'd have 0x plus 0y, which would be just 0. So they can't both be 0. And A, B, and C all have to be integers whose greatest common factor is 1. So integers means no fractions. So A, B, and C, none of them can be fractions. And their greatest common factor is 1. So if you have something like 2x plus 4y equals 6, alright, so if we go through our list, A is greater than 0, so that works. A and B are both not 0, that works. A, B, and C are all integers, but what's the greatest common factor of 2, 4, and 6? It's 2. So let's divide the entire equation by 2. That means we divide everything by 2. And that would be our equation. Alright, so let's look at some of those. So our first examples are just, is it a linear equation, and if so, can we write it in standard form? We have 5x plus 3y equals z plus 2, remembering that standard form is ax plus by equals c. Can we write this one in standard form? Well, does standard form have a z? Nope. Alright, so no, that one is not linear. We can't have a z in there. Alright, what about the next one? 3/4 x plus y equal, 3/4 x equals y plus 8. Okay, do I have an x, a y? Alright, now you might be thinking, well, I got a fraction though. Well, we can change all that. So the first thing is x and y have to be on the same side. So let's move y over. We're going to subtract it to move a term to the other side. 3/4 x minus y equals 8. Okay, so if we go through our list, well, first of all, is it in this form, right? Ax plus by equals c. Is a greater than 0? A and B both not 0. Okay, A, B, and C all integers. That's where we don't have all integers. Okay, what you have to get rid of is you have to get rid of this 4 on the bottom. That's what's keeping us from having integers. So to get rid of a divided by 4, we are going to multiply by 4. We're going to multiply the entire equation by 4. That's going to get distributed. Okay, so 4 times 3/4 is just 3 because the 4's are going to cancel, but you still are distributing it to everything else. 4y 32. There we go. That is standard form. A is greater than 0. A and B are both not 0. A, B, and C are all integers. And we did not check, but our last thing is greatest common factor of 1. And 1 is the biggest number that goes into 3, 4, and 32. Alright, so looking at the next one. We don't have an x, which is fine because A can be 0. It says A has to be greater than or equal to 0. That's fine. So it actually is almost in the right form. The only thing is I don't want a fraction, I want an integer. So what can we multiply this whole equation by? We can multiply by 2. And we're going to distribute that to both, and so you're going to get y equals negative 2. That is standard form. A is greater than or equal to 0. A and B are both not 0, right? Because B would be 1. B and C are integers, right? Greatest common factor of 1. There we go. Alright, let's look at the last one. Can this be written in standard form, or is this a linear equation? It is not. You can't have an x squared There's no x squared in ax plus by equals c, so that one is no. So the next thing we're going to talk about is intercepts. Your x-intercept is the point, okay, it's a point, where your line crosses the x-axis. So right here is an x-intercept. At every single x-intercept, y is 0. Y at this point is 0, right? It doesn't matter where your x-intercept is, at all these points, the y value is 0. Okay? Versus your y-intercept, it's also a point, so remember these are ordered pairs, okay? It's the point where the line crosses the y-axis, so here we go here. And at every single point on the y-axis, x is 0. Okay? So how do you find x and y-intercepts? You plug in a 0 for the other one. If you're finding the x-intercept, you make y be 0. If you're finding the y-intercept, you make x be 0. Also, if the book asks you, or anybody asks you, what are your zeros? It's just referring to the x-intercepts. Okay? It's what you get if you solve this equation, f of x equals 0. You're finding your x. You're finding out which x's give you 0 for your y. Those are your x-intercepts. So, aka, zeros means x-intercepts. So here we have that a valve on a tank is opened and the water is drained. Okay? As shown on the graph, determine the x and y-intercepts and the zeros. Well, what is my x-intercept? Let's list it as an ordered pair. It's right here. It's going to be 4, 0. My y-intercept is going to be 0, 200. Remember when you do ordered pairs, they have to be in parentheses with a comma between them. What is my 0? Well, my 0 is also my x-intercept, right? Now, I am also okay with your x-intercept. You can just write 4. Your y-intercept is 200. And then your 0 would just be 4. So I'm okay with either one of those. But we need to describe what the intercepts mean. Now let's start with the y-intercept. The y-intercept, here it is. The y-intercept means at 0 minutes, there was 200 gallons of water in the tank. Right? None of the water had started coming out yet at 0 minutes. Or instead of saying at 0 minutes, you could say in the beginning. Now my x-intercept means it took 4 minutes to completely empty the tank. Right? At 4 minutes, there is 0 gallons left. So it took 4 minutes to completely empty the tank. The next thing we're going to do is we're going to graph. And you can graph a few different ways. At the moment, if it is y equals, I would suggest graphing with a table. Okay? So because it says y equals, we're going to graph using a table. Let's do this. Graph using a table. All right, so remember our table looks like this with x's and y's, and you're going to get to totally pick whichever x's you want. I would pick some small x's if I were you. I would start with 0. If I put in 0 for x, and put in 0 right there, 1/2 times 0 is 0, right? 1/2 times 0 is 0. Minus 3, we get -3. And I'm going to go ahead and graph that. 0, -3. Okay. And then you know what? I'm going to put in 2 because I want to multiply 1/2 by 2. You can put in whatever x's you want. So 1/2 times 2 is 1. 1 minus 3 is -2. At 2, we're at -2. And I would like for you to have 3 points, so I'm going to put in 4. And a half times 4 is 2, minus 3 is negative 1. Okay, these are lines. You're just graphing parts of the lines, right? These are 3 points that are on this line. So when you need to use a straight edge and draw this in, and you draw it past your points all the way to the ends of the graph there. So we're going to graph another one, and again, if it's y equals, I'd use a table because I'm putting x into that one side, and it really so nicely works out. You might start with 0 again. If you put in 0 for x, what do you get for y? We get 2, so 0, 2. And then this might be 1. Maybe we'll use 1, so 2 times 1 plus 2. We get 4, right? Because 2 plus 2 would be 4, so at 1 we're at 4. And feel free, you can always use negative numbers. 2 times negative 1 plus 2. Well, 2 times negative 1 would be negative 2. Negative 2 plus 2, 0. Negative 1, 0. Okay, and then remember, you're going to draw on your line. If you have a straight edge, I would definitely use it. Remember, a straight edge can even be the edge of a book or something. Okay, so if it's y equals, I would suggest using table. If the equation is in standard form, right, this is ax plus by equals c, graph using your intercepts. So to find my x-intercept, if I remember from my notes, we said y is 0. So to find where it crosses the y, or the x-axis, because I'm looking for my x-intercept, I'm going to make y be 0. So there's my 0 for my y. So this is 3x equals negative 1. Divide each side by 3. X equals negative 1/3. That is my x-intercept. So on the x-axis, I'm going to put a point at negative 1/3. And then I'm going to find my y-intercept, which to find my y-intercept, I'm going to remember that at every y-intercept, x is 0. So if I make x be 0, I end up with y equals negative 1. So my y-intercept is negative 1. Okay, and this is the only time I'll let you just have 2 points. You got both intercepts there. We're going to draw on our line. See something like that. Not a very good line. I'm sure you can draw better lines than I can. Alright, so there's my line graphed, just connecting those 2 intercepts. Let's look at one more of those. So here we have, if you are in standard form, you're going to graph using your intercepts. Okay, it's probably the easiest way to graph using if you're in standard form. So my x-intercept, I'm going to make y be 0, because at every point on the x-axis, y is 0. So 4 times 0 minus, oops, no. 4 times x minus 0. All right, so we get 4x equals 4. Divide by 4. X equals 1. That's my x-intercepts. We're going to plot that at 1 on the x-axis. Then my y-intercept, we're going to make x be 0. All right, so we're going to get 4 times 0. Now, 4 times 0 is 0, but I still have a negative y. So how do I get rid of a negative y? Divide by negative 1. Don't divide by y. Leave the y there. Just changing signs. My y-intercept is negative 4. So I'm going to put a point. Oop, I got it. Put a point on the y-axis at negative 4. There we go. Okay, and we're going to connect these. There's our line. All right, so we talked about several things today. We talked about intercepts, graphing with intercepts. We talked about graphing with a table. We talked about putting equations in standard form. If you have questions on any of that, let me know. If not, I'll see you in class. Have a great day.